Here's a cool math thing. A sculpture I made in 2004 called Salamanders. I was artist in residence at MIT, and I designed a group construction project for 30 students and faculty to assemble with me. We started with laser-cut paper parts, and I had everyone tape together a paper model to learn the structure, following the design of an acrylic model that I brought with me. It consists of 30 identical two-headed salamanders, something of an homage to M.C. Escher. Now, I didn't know the best way to build it on a larger scale from rigid wood components. The problem is the long legs need to weave in front and behind each other in an intricate way. With paper, we can temporarily flex the legs to get them where we want, but there's no flexing wood, so we have to plan ahead. Part of the mission here was for the group to design an assembly algorithm. We came up with a plan based on an equator of 10 salamanders and the north and south polar caps, also with 10 salamanders each. The actual sculpture is constructed from laser-cut wooden parts. These are very carefully designed to weave around each other and connect precisely. There are holes in the feet for screws to hold everything together. Glued to the bottom of each head is a connector for the feet to screw into. The connectors are made from wood spheres I cut on a bandsaw with the proper dihedral angles. At each connection point, there's one head, one left foot, and one right foot coming from 3 different salamanders. The first step was this cap of 10 pieces surrounding a 5-fold opening. We needed 2 of those, so we put the first one aside and then made another. At this stage, we're using as few screws as possible so we have some flexibility for manipulating the legs, checking that they weave properly to make 5-fold stars. We made this in the air, looking at it from the outside, and then carefully turned it over to become the south polar cap, and we put it down on the table so we could work on it. The equator consists of 10 more pieces. Mathematically, they're all equivalent in the structure, but from this perspective, you see 5 of them look like they're lying on their sides, and 5 of them are pointing up and down. Again, there's a lot of tricky leg weaving to get everything right, but it began to take shape, and we could see that everything was going to work out in the end. Now it's ready for the north polar cap that had been held aside. We kept everything loose so the limbs could wriggle around each other, and then screwed it all together. The final step was to tighten the screws. It came out great. It's about 30 inches in diameter, and it's on display now, hanging in the Stata Center at MIT in the Computer Science and Artificial Intelligence Laboratory. If you're in the Boston area, go visit it. If not, and if you want to make your own paper version, there's a template on my website which you can print out, cut out, and then tape together. But I'll warn you, it's very tricky.